Let's take a look at interval notation and compound inequalities. First, what we mean by compound inequalities is two inequalities joined by the word and or. If we use the word and, that's called an intersection. That's what's going on in this compound inequality. This one says negative 5 is less than x is less than or equal to 9. Now, this is two inequalities. We have one inequality right here that says negative 5 is less than x. And the second inequality is over here, x being less than or equal to 9. Now, you maybe don't see the word and, but where it's implied is that we have this first part, negative 5 is less than x. And this second part right here where x is less than or equal to 9. If we were to graph those, what I have in blue, here's negative 5, and I want all the x's that are going to be greater than that negative 5. Negative 5 has to be smaller than the x. So we would use a circle because it's not equal to x, but all the x's have to be greater. So it's talking about everything that's greater than negative 5. Then in red we have x also being less than or equal to 9. So here's 9. X can equal 9, so we'll use a dot. And we want all the x's less than 9. Now, if we look at this picture, I've got an arrow covering the entire number line from negative infinity all the way to positive infinity. However, what we're talking about is that both of these situations have to happen at the same time. So we're not talking about everything. We're only talking about those numbers that are in between negative 5 and 9. So we wouldn't include any numbers out here or any numbers out here. If we're asked to solve an intersection compound inequality, there's really two different ways that you could go about solving it. The first one is that you could separate it into two inequalities. Remember, if I have 8 is less than 3y minus 7, which is less than 23, we could rewrite that as 8 being less than 3y minus 7 and 3y minus 7 being less than 23. If that were the case, then we just go through solving, add 7 to both sides. 15 is less than 3y, divide by 3, and 5 is less than y. And for the second part, we're going to add 7 to both sides. So we'll have 3y is less than 30, and divide both sides by 3 to get y is less than 10. Remember that both of these have to happen. Okay? We need to have, here's 5, here's 10. Y has to be greater than 5 and less than 10. If we were going to rewrite our answer in the same form that the question was presented in, we would combine these into an inequality like this. 5 is less than y is less than 10. Now, the second way we can deal with it is by treating it as a three-sided inequality. So I mean, you know, our normal rules, whatever you do to one side, you do to the other side of an equation or an inequality. We're going to do the same thing here, but it's not just one side and the other, it's all three sides. So when I look at what's in the middle, 14 minus x, I would want to get rid of that 14. So I subtract 14 to get that to cancel. And whatever I'm going to do to any one side, I have to do to all three sides. So I'm going to subtract 14 over here and subtract 14 over here. That'll leave us with negative 19 is less than negative x, which is less than or equal to 28. Our last step is to get x alone, so we have to divide by negative 1. When we do that, we still have x in the middle. But remember that it's going to switch each of the inequalities. So negative 19 divided by negative 1 is now 19. Our less than switches to greater than. Our less than or equal to switches to greater than or equal to. And 28 divided by negative 1 is negative 28. Now, this I don't really like this form. Your book, you'll see it in your book written like this. But the standard syntax is to have the smallest number come first, so negative 28, and x has to be greater than or equal to the negative 28. So x has to be greater than or equal to that negative 28. And x has to be less than that positive 19. Right? Practice writing it in that form. Then you'll always have the smaller number come first. The bigger number comes second. And it looks like x is in between them because x is actually in between those two numbers. The other kind of compound inequality is a union. And that uses the word or. And once again, we have our two inequalities. X is less than negative 4, or x is greater than 7. If we were to graph x is less than negative 4 is over here. X can't equal, so we use a circle. And we want all of our x's to be less than that negative 4. For the second inequality, we find 7. X can equal to 7, so we use a dot. And our arrow goes to the right, because that's where all the numbers are greater than 7. Now, we notice that these two arrows are not going to overlap, so both of these situations can't happen at the same time. That's why we need that word or. One or the other situation can happen, but they can't happen at the same time. If we found a number that was bigger than 7, like 100, it's not also going to be less than negative 4. If we were going to solve a union, just solve each inequality individually. So here we have our two inequalities. K plus 6 is less than negative 4, or 3k is greater than or equal to 14. So just solve each of them on their own. For the first one, I'm going to subtract 6 from both sides. And we get that k is less than negative 10. Or we go over to the one on the right, and we're going to divide both sides by 3. 3 is not a negative number, so we keep the inequality the same, and we're left with 14 thirds. If we were to graph this and take a look to make sure that our union stays the same, stays a union, actually, negative 10 is over here, and we want all of our solutions to be less than that negative number. And 14 thirds is positive, so it has to be to the right. And we want all of our answers to be greater than that one. So again, we have that union where they're not going to, the arrows aren't going to overlap. They're not going to intersect with each other. Only one thing or the other can happen, not both at the same time. The last thing I want to talk about real quickly is called interval notation. Now, this might be the first time you're seeing it as an Algebra 2 student, but it's a nice way to write an inequality that's very condensed. For instance, if we have 2 is less than x, which is less than 11, if we were to graph that intersection would be, here's 2, here's 11. Both of our inequalities are not equal to, so we'll use circles for both of them. And we're talking about x as being in between. If we were to write this in interval notation, we're trying to write the interval, describe that interval that contains all of our solutions. Now, our interval starts at 2 and ends at 11. Since our x cannot equal 2 or 11, we use parentheses. It's just that simple. If we have a very similar intersection with 2 and 11, but this time we can equal both of them, and we're talking about all the x's that are in between. When we write it in interval notation, we'd still write the beginning of our interval and the end of our interval. Since x can equal 2, we would use a square bracket. Since x can equal 11, we would use a square bracket. Okay? So when it comes to writing interval notation, we just identify the beginning of the interval, the end of the interval, and then instead of circles and dots, we're going to use parentheses or square brackets. Now, what if I have an inequality that isn't a compound inequality? It's just x is greater than or equal to 2. If we were to graph it, here's 2. It can equal 2, and we want everything that's greater. Now, I know that my interval begins at 2 and it can equal 2. So I feel very confident about this side, but what about the other side? Remember, with interval notation, we want to describe the beginning of the interval and the end of the interval, and this one doesn't end. So on a number line, what's furthest to the right? It's not an actual number, it's infinity. So our second number, or our second thing in our interval notation would be infinity. And since you can't actually ever get to infinity, you can't equal infinity, so we use a parenthesis. If we have x is less than 11, here's 11. We can't equal 11, but I want everything smaller than 11. Since we're going to the left, what's all the way to the left on the number line is negative infinity. So when we write this out in interval notation, the beginning of my interval is negative infinity. The end of the interval is 11. We can't equal negative infinity, and we can't equal 11. When you're doing your homework and you want to write your solutions to your compound inequalities or any inequalities, you can use standard notation, like using the greater than or less than symbols, or you can use this interval notation.